Hello viewers, today we're going to continue finally the assembly process of this BMW S54 engine. Probably the cylinder block is sitting like that for maybe around a month, I believe so. The other thing which we're going to start is to do some measurements. By measurements I mean we're going to check the deck flatness, we're going to take the straight edge and we're going to see is everything in spec. By that I mean is the block straight as possible. If we're a little bit out of spec it's going to be fine, but I'm pretty sure that we're going to be okay because I didn't see any signs of overheating or something like that. To bend out a cast iron block is going to be really hard. You're going to need to severely overheat the engine. So pretty much I'm sure it's going to be fine. But that matter we're going to measure it. After that we're going to continue with the measurement of the cylinders. By that I mean we're going to measure the taper, we're going to measure out of round throughout the cylinders. We're going to see how good they are. Still the crosshatch on the cylinders are seen, so they are not so bad. As I told you, probably if I have some issues with oil consumption, probably then I'm going to change them, but this is going to be in later state because this is a new swap and until I'm going to be able to drive the car safely and everything is figured out, it's going to take some time. The car is going to sit on idle for a lot of time because there are going to be some issues with the EVS, with the SMG probably. I'm going to need to figure out some things before everything is worked out. So that's why I don't want to change them right now. I have decided that if I cannot do a proper break-in process, it doesn't worth the money to change the piston rings and to not be able to break in them properly. Now with the straight edge we're going to see how flat is the deck of the cylinder block. Yeah, it's not long enough to catch the whole length of the cylinder block, but it's good enough. Only information that I believe BMW is providing is that if you have more than 0.1, once again 0.1 millimeter of curvature along the thickness of the cylinder block, you should resurface the deck. Still, in my believing, 0.1 is a lot. I believe that more than 0.05 or 0.06 of curvature, you should do it also. I have run on engines with 0.05 of curvature without any issues on aluminum and on cast iron blocks, and they are running good without any overheating issues or something like that. If I have more than 0.05, probably I'm going to send the cylinder block for resurfacing. Let's see. Am I going to be able to fit this? Let me show you once again what I'm using. As you can see, 0.05 millimeters. I'm going to try to fit it somewhere to see is it going to go in. But once again, I'm pretty sure that we're going to be fine because these cast iron blocks are going to be really hard to curve them. You should have. Actually, I haven't cleaned perfectly the thickness. But still, I'm not able. Yeah, here maybe it's catching a little bit, but it's dragging, so it's less than 0.5. If I clean up the surface, it's going to be much more better because all of this debris is making a little bit of false measurement. But even with the debris, I'm not able to fit the fuel gauge fully underneath the straight edge. So yeah, I believe we're going to be fine. Just a final measurement time. The most important thing is measuring between the cylinders. This is going to make the biggest issue. So let me. Are you guys seeing what I'm doing? I'm not sure, but yeah, I believe you see. So once again, let's try. And actually between the cylinders is the most cleanest part, so that's why it's impossible to fit the fuel gauge there. Let's try like that. And here you should pretty obviously do it every possible way you can locate the straight edge. Once again guys, I'm pretty sure that I'm not going to have any issues with this block. Yeah, as you can see here, I can fit it, but once again there is some debris here. If I clean them up, I'm going to be fine, I'm pretty sure. The most important thing is this measurement here, to not be able to fit the filler gauge between the cylinders. This is the most crucial measurement. So once again, the stretch edge along the cylinder block deck, and if we zoom in a little bit, 0.05 millimeter. And the other thing which people are doing is just take some white and try to see under the straight edge. It's going to be really hard guys to show you what I mean, but yeah, I cannot see anything underneath the straight edge for sure. Of course, I'm going to clean up the thickness of the cylinder block. It is flat even like that. Imagine when I clean up all the debris, it's going to be even better. So I'm pretty sure that I'm not going to have any issues with the thick of the cylinder block. Now the next step is going to be to measure the cylinders for taper and out of round. We're going to see how good they are. I'm going to use the torque plate and torque it, because this is going to make the measurement much more accurate than now. For measuring the cylinders for taper and out of round, we're going to use the good old trusty torque plate with the sleeves. They're going to be installed like that. We're going to use the original shims and the original bolts. For torquing up the torque plate, we're going to use the original torque spec for the bolts, and yet to be accurate as much as possible, we're going to use a cylinder head gasket, which I'm going to use the old one. And pretty much this is going to be how it was installed. It was installed something like so. The dowel pins, they go inside. So now let me show you first of all. We're going to remove this, and actually even on the torque plate we have enlarged holes for the dowel pins here and here. I believe they should match like on every 6-cylinder engine. Okay guys, let me place the camera because it's a little bit heavy. Okay, like that. Now it's fixed. Actually I'm going to need to put a little bit of oil on the threads of the bolt, because on all BMW engines, when I'm assembling a cylinder head, I'm putting a little bit of oil on the threads. This is going to make the job a little bit easier and not going to stress so much the threads in the block and on the bolt, of course. And it's not going to cause any issues. Never had an issue applying oil on the threads of the bolt. Just going to fit them, and after that going to loop them. I have looped all the threads and the heads of the bolts. Now I'm going to torque all of them to torque spec, which is 30 Newton meters and 2 times 90 degrees. I'm not going to record this. I'm going to record this boring process when I'm assembling the real cylinder head. All the bolts are torqued to spec, and now I'm going to clean up a little bit the cylinders from the oil, and we're going to start measuring everything. Just to show you, this is what is the diameter of the cylinders, 87 millimeters. If it's not resurfaced or anything like that, it pretty much looks that it haven't been touched lately. But let me show you the information from BMW which I found out. So this is the bore diameter, stage 0, which means is the original diameter, 87 plus 0.0, let's go 1. The second stage is 87.05, and the third stage, the biggest stage I mean, is 87.2. This both specifications is for a reconditioned or new cylinder block, and the specification is for out of round 0.005 and for taper 0.01. The thing that I know from different BMW engines is blocks, especially, is that the out-of-round specification recommended. Once again, this information was for a new cylinder block, not for a used one. For a used one, the recommended out-of-round is going to be somewhere around 0.01 and 0.02. More than that is kind of bad, and for the taper, more than 0.02 is once again not so good. We're going to do some measurement through the whole 6 cylinders with the bore gauge indicator, and we're going to see how bad is the cylinders. And after that, yeah, of course, we're going to measure one piston to see what is going to be the total wall clearance between the cylinder and the piston. As you can see here from the information, once again, like on every BMW cylinder block actually, is 0.15 millimeters. This is the total clearance between the piston and the cylinder wall. Okay, so I'm just going to use my micrometer to set up my bore gauge indicator, just to show you guys. As you can see, I have set it up exactly to 87 millimeters. Okay, so let's see how bad they are. I'm going to measure on 3 levels and on 3 angles. This is going to determine the out-of-round and the taper on each cylinder. So of course I'm going to start from the top. After that, just quickly show you. Here we have around 2.5. So as we can see here, around 0.03. Or yeah, around 0.03. If we go a little bit lower, let me try to show you a little bit better in details. As we can see, if we go a little bit lower, we are at around 0.01. This quickly means that we have at this point, on this angle, taper of 0.02, which is not the perfect case scenario, but once again, this is a used engine, high revving used engine, which is normal to have some wear on it. Just show you one of the cylinders. So once again, I'm going to measure it like that on the top. After that, I'm going to rotate it to 45 degrees, and once again on 45 more. So once again on 3 angles. After that, I'm going to go in the middle. I'm going to measure once again like that, and on the bottom. And once again on all the levels, I'm going to measure 3 times. So I'm going to do this through the whole 6 cylinders. So let me show you the results. Sorry for my drawing skills and writing. I really hope that you guys are going to understand. So this is the cylinders from 1 to 6, and this is the levels which I have measured. This is the top measurement, the middle measurement, and the lowest measurement on the lowest point of the cylinder. So as you can see here, probably cylinder number 1 and 6 are the worst, because the out-of-round on cylinder number 1 in total, this is the lowest number, this is the highest number. We have 0.035 millimeters of out-of-round, and on cylinder number 6 is 0.03 millimeters. About the taper, I believe that the spec was between 0.05 and 0.01. Yeah, I'm out of spec, of course, but this is old engine, so it's not big of a deal. The biggest taper which I saw, I believe it was 0.02. As we can see here, 87.05, and the lowest number is 87.005, which means the total taper on this measurement here is going to be 0.02. I know it's really hard to understand me, guys. I'm just showing you what my measurement. I really hope for at least one person this is going to be helpful. By that I mean comparing his results with my results. And once again, I'm still going to, as I told you, I'm going to run the engine like this. I know in the perfect case scenario, you're going to want to bore out the cylinders, use a new piston rings and new pistons, but I'm not going to do this because, once again, I'm not going to be able to do a proper break-in process. Later state, probably going to do it, but for now, I'm going to run it as it is right now. So this is my results. We have out-of-round, we have taper. Yes, I know that it was going to be like that. I haven't measured a cylinder block this old that doesn't have taper or out-of-round. All of them are like this. Not all of the owners want to rebuild them, and they run the engines like this without any issues. I know this is going to be a high ref engine, is going to be a little bit more risky, but still I'm going to take this risk. So this was the results. I just wanted to see how bad it is. Okay, so I'm going to try to measure one of the pistons. So let's see what is the diameter. I'm going to measure on the piston skirt, of course. As we know, on the aftermarket pistons we have some spot where we should do our exact measurement, but you just need to aim the lower part of the piston pin and you can measure somewhere around here. So let's see how much is going to be the diameter, and by that we're going to determine what is going to be our clearance between the piston skirt and the piston wall. I believe somewhere around this. So we are at around 96, between 95 and 96. Okay, so from our measurements, 96.95. This means when the engine was brand new and the cylinder was exactly 87 millimeters. Originally the engine had around 0.05 millimeters of clearance between the piston skirt and the cylinder wall. And right now, as we saw, the biggest measurement which we had was 87.035, which should be added to this 0.05. So this means we're going to run with the biggest clearance, because not all of the clearance is going to be like that. This is the biggest one we can measure. The biggest one which we're going to have is 0.085, which is pretty much around the middle of the permissible range which BMW is giving, which is 0.15. I'm pretty sure the engine is going to run like this without any issues. I just need to clean up a little bit the pistons, because actually they look pretty good for an old engine. You can see all the curves and grooves on the valves and stuff. Still, the oil ring needs cleaning for sure. It looks kind of dirty and clogged, but we're going to take care of this. We're going to leave it like that for now. We're going to run with this clearance. Once again, this is going to be the biggest clearance, because on some measurements we have exactly 87, which means there we're going to be in spec, but still with this out of round, yeah, it's not going to be exactly that, but doesn't matter. So now I'm going to remove once again the torque plate, and the next thing which I'm planning to do is to paint the cylinder block, because I don't have anything else to measure. Okay, I decided to switch on new teeth because it's much more faster to work than Ista. So just wanted to show you the spec for the cylinders. This is the cylinders, sorry guys, the pistons. This is the diameter of the OEM piston, 86.965. Like I told you, I have measured somewhere around that, which means we have around 0.35 millimeters of clearance originally from the manufacturer, because originally the cylinder is 87 millimeters. So the clearance between the piston and the cylinder wall is going to be 0.035 millimeters. And as we can see the spec, permissible total wear tolerance between piston and cylinder is 0.15, which means we're somewhere around in the middle. This is probably one of the most time consuming things that I have done lately. So I'm pretty much ready with the cylinder block for painting. I prepared everything. I think I have covered everything that needed, all the threads, all the surfaces that's going to be needed to be clean when reassembling the engine gasket wise. So on the next day, the engine block is once again on the engine stand. I have cleaned up the deck of the cylinder block, and yeah, it's not of course like a machine shop going to do it, but it's perfect in my opinion. I see some little bit of grooves. Let me show you. As we can see on some places, which is normal for this old cast iron box. I'm pretty sure that's not going to cause any issues. I have seen even worse, and the engine is running with those. But yeah, as we can see, on most of them we have some grooves. And if you go on a machine shop to clean up the deck of the cylinder block, they're going to disappear. But the main thing that actually, let me show you. If we take a closer look, we're going to see the original machining. So for sure this cylinder block haven't been machined previously. And the main reason that I don't want to machine the deck of the cylinder block until it's really needed is because these S54 engines doesn't have different thickness of gaskets, cylinder head gaskets, And when you resurface your cylinder block and the cylinder head several times, you need to go with really oversized cylinder head, which is, I believe it was 1 mm, and the original one was 0.64 mm, which I don't want to go with so much thick gasket. I'm not a fan of a thick head gaskets, so that's why I'm going to try to run it as much as possible without touching the cylinder block. Just a few words, I didn't say anything about why I'm using the torque plate. The main reason I'm using it when measuring the cylinders for out of round and taper is because when you tighten up the cylinder head and torque the bolts to spec, because of the tightening force of the bolts inside the turrets, the cylinders are going to be distorted, and then you're going to have a different measurements through the whole cylinders. I have tried this is true. I have a video actually about this, comparing measuring the cylinders with and without the torque plate, and they were a difference for sure. This is why every time you're doing reboring or measuring like we did, you're going to need the torque plate with the head gasket with the original bolts, which should be torque spec, and then you should either rebore your cylinders or just for a measurement purposes to see where are you with this cylinder block, how bad are the cylinders. We're going to continue with the crankshaft installation. Once again, for those of you that have watched my older videos, I have showed the crankshaft that is in pretty good condition. I'm once again going to reuse the main bearings. I'm going to use the original ones because rarely these 6-cylinder old generation engines are having issues with the main bearings. And actually, of course, this is the original bearings. Let me try to show you. As we can see, this is the original bearing. And yeah, I'm going to reuse them. As we can see, they are looking pretty good. Yeah, I'm going to need to clean them, of course, but they have just a small amount of wear. As we can see, some drags, but nothing excessive. And you're never going to lose oil pressure for a line like this. So actually, let me show you the cross hatch which we have left in the cylinders. I know it's not a lot, but we still have it on some places, not on everywhere. As you can see here, we are missing a lot, but once again, I'm sure that it's going to run like this. Probably we're going to have some minor oil consumption, but when I clean up the piston rings, especially the oil piston ring, it's going to be much more better than it was how it was before. Okay, so as I told you, we're going to continue with the crankshaft. Pretty much I have nothing to do with the main bearings because I'm going to reuse them, which means if the bearings are looking like that in this condition, for sure we don't have any issues with the main journals. But just for showing purposes, I'm going to show you how to measure them and what are their sizes. And I have opened up here the specification for the crankshaft. It's exactly as on every M50, M52 and M54 engine. The journal is around 60 millimeters, but if we need to be specific, it's 59.96. This is the yellow, the green is smaller, and the white is even smaller than this. Most of the time you're going to have this spec, 99% of the time, the yellow one. And yeah, we have some oversized. If you want to resurface your crankshaft, you're going to have two service bearings with 0.25 and 0.50. And this is the clearance, once again, like on every BMW 6-cylinder engine, from 0090 to 0052. The only difference on this S54 is the clearance on the con rods, the con rod bearings, but more about this in the next video, because I just want to assemble the crankshaft with the main bearings and yeah, the oil nozzles for sure. I want the crankshaft to be installed, and in the next video I'm going to do a separate video only for the con rods, because we're going to do some interesting experiments there, and I want to do a separate video about this because it's going to get really long if we do it in this video. So the crankshaft, as you can see, it looks fantastic, I'm not going to lie. It's really interesting, the covering of the counterweights. As we can see here are blue, and here is more violet or brownish. And the biggest point which you can see that the crankshaft is relatively a big mileage or small mileage is here. So this is where the seal, the rear crankshaft seal lies, and as we can see, it's pretty obvious where it lies. 99% of the time, the crankshafts on these BMWs have groove where the seal is sitting, and as we can see, here is pretty much almost 100% flat, which means that this crankshaft is really at low mileage, or I believe so, because I haven't seen for years a rear main seal surface to look like this. So yeah. Now, just for showing purposes, I'm going to use my micrometer to show you the, let's say on one of the main journals, what is the exact diameter of the journal. As we saw, it should be around 59.96. Here is going to be much more easier. Okay, so let's find how much it was. Here is 60, so we should go for less, somewhere around here, but still we're going to try to see are we right or wrong. So let me try to show you. Yeah, the sun is out, so yeah, this feels exactly right. Let me show you. Okay, let me zoom in. Yeah, now I'm going to walk it. So, as we can see, okay, let me rotate you guys. So, as we can see, exactly 59.96. which is exactly in spec. As I told you, I was pretty sure that there will be no issue with it. When you see bearings that are looking like almost a brand new ones, you are not going to have issues with the journal. You're going to have issues when the bearings are worn out, but in this condition I'm pretty sure that all of them are going to be fine. In the next video we're going to measure the control journal, but for now we have just measured the main journal. Now I'm going to install the crankshaft in the cylinder block and going to tighten up all the bearings. We are not going to measure the clearance because I'm pretty sure that we're going to be in spec, which we saw. Once again, if you are out of spec, you are not going to have bearings that are looking like that. That's why there is no point to measure any clearance. The only time there is a point to do it is when you are changing the bearings. When you are changing the bearings, you should check it for sure. But when you are reusing your old ones and they are looking like a brand new ones, there is no point of measuring it. Okay, after ultrasonic cleaner, all the caps are ready to be installed. As you can see, they are looking much fresher than before. All of them. I have cleaned these flanges which are holding the suction pipe for the oil pump. Actually, they are different. I believe they were on cap number 3 and 5. I need to recheck. I have cleaned all the oil nozzles. I'm going to start reassembling. I'm going to start, of course, with the oil nozzles. So always start with this because in later state probably you're going to forget about them. So before installing the oil nozzles, it's always a good idea to take a brake cleaner and spray from this hole here to see is the oil nozzle cocked or not. Let me show you. Like that. Now I'm going to start assembling them. I'm just going to put just a tiny smidge of thread locker on the bolts for the oil nozzles. So it's with H5. And here I'm going to torque these bolts to 10 Newton meters. For now I'm just going to tighten them by hand. I'm going to continue with the installation of the bearings, the main bearings. The grooved bearing, as we can see, this groove here, is installed on the box side. We have a, let me show you. We have a notch here, which you cannot mess it up. It's located on the oil nozzle side. I'm just cleaning as good as possible. Yeah, these surfaces where the bearings are going to lie, I have cleaned them already, and I have cleaned the threads for the main bearing bolts. I have cleaned them and degreased them. Okay, like that. I'm going to put some oil in the holes, the oil fit holes for the bearings. I'm going to put assembly loop on the bearings itself, but I want to have some oil in the channels. Yes, you can see some oil is dripping down. I'm doing that because I have degreased everything, and I'm not sure how much time the engine is going to stay like this. And I don't want this block to develop some rust in the oil galleries. This is why I'm filling these channels, oil supply lines, with oil. Now I'm going to put some assembly loop on the bearings, and we're going to install the crankshaft. Okay, I have installed all the bearings on the cups, and once again we're going to say that these bearings should be changed, but I don't think so. Just some bearing knowledge: you're never going to lose a oil pressure for a line along the whole bearing. You're never going to lose a pressure from this oil pressure. The only time you're going to lose a oil pressure is when you have a line which goes through the side of the bearing, because if you have a line inside the bearing, still you are not going to lose oil pressure because the oil cannot escape from the side of it. When you have a line like this is not going to cause an issue. I can assure you this, guys. And yeah, let me see which one looks bad. Not so bad, but still, for people, some people are going to go crazy and going to say you need to change this. Yeah, here we have some lines also, but I'm not sure where this came from, but it's not going to cause any issues. It's like old oil here, and I'm not thinking to scrap it out. I'm going to leave it like that. So once again we have a line here, which once again not going to cause any issues for sure. So now I'm going to see where these plates should be installed, because I forgot. I'm going to see in the menu, and we're going to use these new bolts. You're always going to need to use a new bolt when installing the main bearings. Doesn't matter what people do. This is the new bolts, and pretty much they are the same like the old ones. BMW haven't changed them, not like the other engines. They're still using the same bolts. And yeah, we should have in total 14, I believe. I'm going to count them out, and this is the part number. Yes, actually maybe here. Yeah, here is a little bit easier to set. This is the part number. And now let me open it up, and here once again I'm going to lube up with some engine oil the threads slightly and the head of the bolt, of course. So let me check the torque spec and start reassembling the main bearings. Okay, so torque spec, main bearing screws, it's called here, kind of strange, but so if we go along the line, S54, 25 Newton meters plus 50 degrees. I am surprised that it's so small, but BMW is saying this, so I cannot argue with them. Okay, so main bearing cup number 1. As we can see, we have numbering on all of the caps. So this is number 1, and along the crankshaft we're going to have 2, 3, 4 and 5, and on 6 we're not going to have a number because it's axial bearing and you cannot mess it up. And on number 7 you are once again not going to have a number because it's pretty obvious this is going to be the last cap and you're going to know that it's number 7. So the installation position is like that. We have these channels here, and they should be pointing the channels on the opposite side on the bearing which is installed on the cylinder block. So the numbers pretty obviously should point to this side where the oil channel for the oil pump is located. So actually, yeah, I'm going to put once again assembly loop on all of the bearings. So it's going to become messy. Once again, before continue, you need to be sure that the holes for the main bearing bolts should be clean and degreased, because if you have some oil inside, it's possible to crack up the cylinder block while tightening the bolts. I'm going to start installing the bolts. Once again, I'm going to put some oil on the threads of the bolt and on the head. It's a really messy job, guys, but this is how it is. Okay, on cap number 3 we're going to use this, let's call bracket, which is holding the oil suction pipe for the oil pump. This is the bracket with looking like that and oriented like that. So on cap number 5, this is the other bracket with this type of hole, once again oriented like the other one, not like that, but like that. I'm going to start from the middle, from the middle, and I'm going to go along to the outside. So once again, the first torque spec is 25 Newton meters. So after torquing all the bolts to 25 Newton meters, now I'm going to undo the bolts on the axial bearing, which is on cap number 6. Like that. I'm just going to leave them loose. And now I'm going to tap the crankshaft backward and forward, so to be sure that the axial bearing is going to sit up properly on its place. This should be enough. So now I'm going to tighten them up once again to 25 Newton meters. And now we're going to do the last stage, which is 50 degrees. Okay, so I'm just going to do my mark, so to be sure that I'm not going to miss any of the bolts. Okay, so all the bolts are torqued to spec. Okay, so before call it a day, I want to reinstall the knock sensors, which in the disassembly video I said that I'm not going to remove because they are kind of gentle, and when you remove them and reinstall them sometimes they fail. but in the end of the day I decided to remove them so to be able to paint the block a little bit better. So I'm just going to reinstall them. And about the orientation of the pucks, there is no locking pin or something like that to orient the puck, but I have made my picture about the orientation, so to be sure how to install it. It's not an issue how you're going to install it, it's an issue about the installation. Is it going to interrupt something? So this one was something like that, this one is like that, and the last of it something like that. So I'm pretty sure that 1mm is not going to cause any issue. So let me torque them to spec. So the torque spec for this knock sensors is 20 Nm. In the workshop manual it says plus minus 5 Nm, but I'm going to torque them to 20. Okay, like that. So okay guys, I'm going to end up the video here. I'm going to do a separate video about the con rods because I want to show you some things there. We're going to do some experiments between ARP bolts and the OEM bolts. We're going to see what is the difference between both of them, and we're going to see is it safe to use them or not. Hopefully it was interesting for you guys to watch it. We're going to see each other in the next assembly video.